as I mentioned in the last video, meaning lesson 1 of unit 11 part 2, you could do part of this test in your calculator. So wait for it. If you have a TI 83 or 84, you want to get into where all your tests are. So you push stat and scroll to your tests. And we're doing chi-square goodness of fit. I'm going to scroll up because that's the quickest way to get there. Mine is option D, chi-square goodness of fit test. And then it's weird. This is not what it usually looks like. So it's saying observed L1, expected L2, and those are your only options to put stuff in for observed and expected. The observed and expected are what we actually looked at from the data, where these were the actual NHL players selected. We said a fourth of 80 gives us these expected values. These are what we're needing to put in, but we need to go put them into L1 and L2. So that's what I'm going to do. So I'm going to push stat, edit. I'm going to clear out the crap that's still sitting in there. So into my observed, I'm going to put in the 32, 20, 16, and 12 that they observed from this sample of 80 players, and that they were expecting uniformity or testing uniformity. So these 20s. So I'm going to push again. Stat, test, chi-squared goodness of fit test. Make sure you're not selecting chi-squared test. That's what we'll do in the next lesson next week. So now it's okay to leave. My observed is L1, my expected is L2. My degree of freedom should not be 5. I have no idea what it defaults to. This is just what I apparently did last year when I last did this lesson. But I had 4 categories. We said that meant 3 degrees of freedom. So we see the test statistic that we calculated. We see the p-value that chi-squared CDF also could find you. Don't worry about any of that gibberish. But I do want to point out, if you go... Oh, you can't do that. I thought there was a way to do that. Oh, also, I'm just now reading. Apparently, some of your calculators are not going to have that. So the TI-83s, some of the 84s might not see chi-squared goodness of fit test. So if you're like frantically searching through your calculator, sorry, apparently it's not there. And apparently, I think it's the newer TI-84s. List is called. I'm gonna, maybe it's even on mine. Sorry, I probably should have figured this out before I... I'm gonna hit stat edit. No. I know I've seen it. I'm trying to remember how to find it. Okay, whatever. Not a big deal. There is a way to look at the data of finding the actual calculations that your calculator ran through to find this for you. Whatever. You don't really need it. Just use your calculator to get those for you. So there is one remaining example that's on here. So when you get to the step where it's telling you to do it, then by all means use your calculator. Just do it that way. I will point out one small difference. This is not testing uniformity. So it's not saying that the car colors should all be equally represented. This is saying that either the wait, is it? You think I, again, should have been a little more prepared than this? Okay, so they're just, yeah, they're not testing uniformity. They're testing 23% should be white, 18% should be black, 15% should be silver, 2% should be green. That's what they're saying. If it's the same as what North America is, this is what it should be following. So it's not just going to be saying that it is uniform, it's going to be saying it is the same as North America, or it's just not the same as the rest of the distribution in North America. When you go to find the expected value, you're going to take your total, which is 300, and just multiply by its respective probability. So, for example, we should be expecting, if the null hypothesis is true and it's actually 23% will turn out to be white, you should expect 69 white cars in the sample. We had 84 white cars, so that's a bit of a difference. If it is true that it truly is the same as North America, I would expect 18% of 300 to be black cars, which is 54 cars. we had 38. So already I'm seeing some evidence that it is not the same as what it is for North America. You should be testing to see if we have convincing evidence that it's the same or not the same as the distribution that it is for all of North America. The other thing I'm seeing, when I had typed these out, I had some other things on here, and then I apparently never deleted it. So the part where it says a sociologist claims, that's residue from another example I was going to throw on here, and then I took it out. So feel free to scribble it out and try and ignore it to the best of your ability. I will never be going over that example. All that you're going to see on your notes is the answer key for this last example, and that should get you through chi-squared goodness of fit tests. Emailing me your questions. Hopefully you should actually be watching these videos, because I was just looking on YouTube and most of the other videos have about 3 or 4 views on them.